Hello students, today we will study vectors in 2 dimensions and 3 dimensions along with 2 important operations, the dot product and the cross product. By the end of this lesson, you will clearly understand their meaning, properties and real-world applications. A vector is a mathematical quantity that has both magnitude and direction. Examples include displacement, velocity, acceleration and force. We draw a vector as an arrow, and algebraically we write it in terms of components. The concept of vectors was formalized in the 19th century to study electromagnetism and mechanics.
Sir, why do we need vectors when numbers are already there?
Excellent question. Numbers, or scalars, only show magnitude. But in physics, we often need direction too. For example, if I say a car is moving at 60 km per hour, you only know speed. But if I say it is moving at 60 km per hour towards the north, that is velocity, a vector. In 2 dimensions, we write a vector A as A is equal to A1 into I cap plus A2 into J cap. In 3 dimensions, it becomes A is equal to A1 into I cap plus A2 into J cap plus A3 into K cap. Here I cap, J cap and K cap are unit vectors along the x, y and z axis respectively. The basic operations are addition, A plus B is equal to bracket A1 plus B1, comma A2 plus B2, comma A3 plus B3 bracket. Subtraction, A minus B is equal to bracket A1 minus B1, comma A2 minus B2, comma A3 minus B3 bracket. Scalar multiplication, K times A is equal to bracket K multiplied by A1, comma K multiplied by A2, comma K multiplied by A3 bracket. Magnitude, modulus of A is equal to square root of A1 square plus A2 square plus A3 square. Example, if A is equal to 3, 4, then magnitude of A is square root of 3 square plus 4 square, which is equal to 5.
Sir, why do we calculate the magnitude?
Magnitude tells us the length or size of the vector. For velocity, its magnitude is simply the speed. The dot product of 2 vectors is defined as A dot B is equal to A1 multiplied by B1 plus A2 multiplied by B2 plus A3 multiplied by B3. Geometrically, A dot B is equal to modulus of A multiplied by modulus of B multiplied by cosine theta, where theta is the angle between the 2 vectors. Some important properties are, it is commutative, A dot B is equal to B dot A. It is distributive, A dot bracket B plus C bracket is equal to A dot B plus A dot C. If the vectors are perpendicular, their dot product is 0. Applications, work done is equal to force dot displacement. Projection of one vector on another. Example, if A is equal to bracket 2, 3 bracket and B is equal to bracket 1, 4 bracket, then a dot B is equal to 2 multiplied by 1 plus 3 multiplied by 4, which is 14. The cross product of 2 vectors is written as A into B is equal to bracket A2 multiplied by B3 minus A3 multiplied by B2 bracket into I cap minus bracket A1 multiplied by B3 minus A3 multiplied by B1 bracket into J cap plus bracket A1 multiplied by B2 minus A2 multiplied by B1 bracket into K cap. The magnitude is modulus across B equal to modulus A multiplied by modulus B multiplied by sine theta. Its direction is given by the right-hand rule. Some properties, it is not commutative. That means A into B is not equal to B into A. It is distributive over addition. Applications, torque is equal to R into F. Area of a parallelogram is equal to modulus of A into B. Angular momentum is equal to R into P. Example, if A is equal to bracket 1, 0, 0 bracket and B is equal to bracket 0, 1, 0 bracket, Then A into B is equal to bracket 0, 0, 1 bracket. Vectors are very useful in advanced fields. In electromagnetism, the Lorentz force is Q multiplied by bracket electric field plus velocity into magnetic field bracket. In aerospace, navigation and orientation depend on vectors. In machine learning, dot product measures similarity between vectors. In robotics, kinematics and dynamics are modeled using vectors. So students, today we understood what vectors are, how to represent them, and how to use dot product and cross product in mathematics and physics. These concepts are not only exam relevant but also form the backbone of many modern technologies. Thank you for your attention. See you in the next class. Jai Hind.